Thank you. Okay, let's go, Dr. Mueller-Solger. Let's get your report, and then we'll wind up back with the final part of Dr. Goodwin's.
Oh, I'm on? All right.
You're on.
I'm on. Well, thanks again for having me this morning, for having me back. Thanks for giving me a chance to talk to you. I'll talk to you a bit briefly. I'll try that anyway. And in order to be brief, my major professor always told me that in science, other places as well, but in science, a picture or an image is worth 1,000 words. So I did bring a PowerPoint, dangerous though that is around here. So could I please have my slides? And I was asked to tell you about the workshop we just held last week, and I will do that. But in order to set the stage for that, I will tell you a little bit about our observations regarding water and fish last year, this past year, 2011, which was a very interesting year in both those regards, and of course influenced then what people looked at and talked about at this workshop. So I'll do that really quickly, and maybe I can actually advance the slides. Oh, works. So in case you missed this, 2011 was actually very wet. This here shows the graph showing precipitation in the northern part of the Sierra.
This year meaning 2012.
2011 was very wet. This year is 2012, and that's also on that graph. You're right, Phil. Sorry, Chair Eisenberg. And you also see there indicated water year 2006, which was the previous wet year that we had, and then in between we had a few very dry years, as you know. So that was a good thing. Thanks to that, we then had high inflows and outflows. This here actually shows a time series starting in 1956 water years of inflows in sort of, on the screen there, it looks kind of greenish, outflows bluish, and then in purple, those bars at the bottom are actually the export volumes, and all of those are volumes, actually, water volumes, cumulative over the course of the year. And so we also had record high exports again, thanks to all that water that was available. And finally, last on the waterfront, actually this is a bit more regarding salinity, but highly associated with outflows, is the much talked about X2, and in particular the fall X2 values. Fall X2 is September and October average X2, and if you recall, X2 is the 2 parts per thousand isohaline location in kilometers from the Golden Gate. And the smaller it is, the farther westward this ominous X2 thing is. And really, X2 is just an indicator for the position of the low salinity zone, or in general, the salinity gradient in the estuary. And it's been related in the past to the abundance of all sorts of organisms, and that has led in the past to X2 regulatory actions in the spring. And then more recently, in 2008, it also made it into a regulatory action in the fall Fish and Wildlife Service's Delta Smelt biological opinion. And, of course, there was a lot of talk about this last year. Anyway, last year we finally, after more than a decade, had a relatively low value of X2, meaning a westward low salinity zone again in the fall. And that was because of all that water that was available in the system. And then a little bit about the fish. So I'm sure you've all heard that Delta Smelt did really quite well in 2011 relative to about a decade worth of numbers that were really low prior to that, the highest value since 2001. And also this here shows the fall abundance index, and also almost 12 times more than the year prior to that, 2010. And then similarly, longfin smelt did a bit better. Not quite as great as Delta Smelt, but still. But on the other hand, some other fishes that we've been following, threadfin shad, which is non-native, but one of the 4 podfish species, did not. And winter run Chinook salmon, one of the longest, the longest listed aquatic species here since 1989, did very poorly. Those are the returns to the Sacramento River of winter run salmon. So, what happened?
Pat?
Yes.
Does that mean that flow matters overwhelmingly in the case of the smelt and not so in the others?
Well, I'll get to that because that's exactly the question here. What happened? Obviously, lots and lots of things happened, and people do want to put things together relatively simply. And I almost asked for this question here because I had the water and then the fish. But of course, many other things are going on as well. And so at the workshop that we just had this past week, we had some of the answers, like what you just asked for. Some. I'm sure there are others as well. And then, of course, many of those answers were preliminary, and I'll get to your question here in a second. I just want to say, so we had specifically a session about salmon on Thursday, almost all day Thursday. We had a session about delta smelt life cycle modeling, and that just came up here with some of what Dr. Goodwin talked about on Wednesday. And then we had a long session about what happened regarding the fall, low salinity habitat, and delta smelt specifically. And I'll talk about this in a little bit of detail. Just before I do, though, the workshop was, I think, quite successful, probably our largest ever. We had around 350 registered attendees. We worked together with QEMF, as Peter already pointed out. We had 56 talks in 11 sessions, including the 3 I just mentioned, but there were others as well on water quality, on food web, on the North Delta, on all these cool technologies, including the smelt can, on modeling tools, and a long talk by Peter Goodwin, 40 minutes worth of a talk, which was very good. And then we also had lots of posters with lots of information on them. So what did we then hear? Chinook salmon, as I said, we had a long session on Thursday. And so now, in answer to your question, more or less, obviously salmon go in and out of the rivers. They spend part of their life in the river, then go through the estuary, and also spend a good part of their life as adults, as shown here on this little life cycle slide, in the ocean. And, obviously what happens in the ocean, in the river, in the estuary all matters to how these fishes actually do. There was a bit of talk about the 4 H's, so hydrology, the flows, harvest, hatcheries, and habitat. Hatcheries was in a nice talk by Rachel Johnson. A lot of our fish, our salmon now, the majority, and more so, are of hatchery origin, not wild-caught. And Rachel Johnson particularly talked about what that means to the resilience of these populations of salmon overall to future changes, and how that's perhaps not such a good thing. So survival of migrating juveniles seems to be getting worse, and that's part of the story, certainly. And at least in parts of the system, and it seems to currently be best in the North Delta and Sacramento River corridor, where Russ Perry from the USGS reported up to about 70% survival, but then poorer in the Central Delta, depending on the route, and poorest in the South Delta, where they've been following the salmon there over many years by now, using various types of tags, and it seems to be getting worse, but at this point it's usually less than 10%. This was presented by Pat Brandis of the Fish and Wildlife Service.
Less than 10% of what?
10% of the fishes that go into the delta on the San Joaquin end and then try to get through the delta, and they are looking at Chips Island, who makes it there, basically. And they've also been following them around with acoustic receivers more recently. And similarly, the North Delta was done sort of in the same way. They were released upstream in the Sacramento River and then followed along these different routes through the delta to see who basically made it through. And the flow. So generally, this was actually in several studies. Generally, survival is greater at higher flows. And Brad Cavallo from Kramer Fish Sciences actually had an interesting talk where he thought that perhaps the duration of flow direction, going toward the pumps, going toward the ocean, wherever they go with the tides and the rivers, might be an important or better metric that just simply flows. So that was interesting. But overall, higher flows, better survival. And then we also had one interesting talk, which was a rather small-scale, spatial-scale study concentrating on the Sacramento River around the city of Sacramento, and particularly the water intake structure, as something like what at the time when they set up the study was thought to be a somewhat similar structure to what the BDCP intake things might look like. By now, they've actually, I think, morphed into the short type thing, but in any case, they were interested in entrainment into such a structure in the Sacramento River of juvenile smolts, salmon smolts, as well as predation associated with such structures, because we know that predation is associated with such structures. And they, in fact, found really high rates of predations and lots of predators in that particular stretch of the river. And, if this is any indication of what the river is like in general, no wonder that fish are having a hard time getting through, especially when the flows are such that they aren't helping them get out. It's becoming perhaps more and more, I don't know, a gauntlet.
What is a tethered salmon smolt?
I had a feeling you'd ask that.
Visually, it appeals to me.
It is
they're
quite
wearing
a visual
harness,
thing too. But literally,
smolt.
they attach little poor salmon victims from a hatchery, of course,
Yep.
to a little line, and they also attach a transmitter so they know what happens, and then they just wait and see what happens to this poor fish as it
And 69%
eventually gets eaten.
get eaten.
Obviously,
the
and the duration was an hour that they looked, but obviously, a tethered fish acts a bit differently from a fish that's really swimming. So it's not the perfect analog to what happens in the real world. However, there's definitely, and then they overlaid their predation with their predator densities, which they'd gotten with some other cool technology, which was a DSC camera, which is a sonar type camera for looking under the water, and so it was a pretty convincing case for predation is pretty high, at least in this stretch. So I'd also like to point out that we are reviewing, the IEP does regular reviews of its various monitoring and research parts, and we have our own independent science board type thing called the Science Advisory Group, and currently we will be reviewing our juvenile fish monitoring program, which focuses on juvenile salmon, as well as the juvenile salmon survival studies that we're doing, and there is a public scoping meeting on May 11th for that. So then turning to delta and longfin smelt. Actually, longfin smelt didn't come up too much during this entire conference, but a little bit. By the way, longfin smelt were, I think, on April 2nd now, as of April 2nd, are candidate species for listing under the U.S. Endangered Species Act, the Federal Endangered Species Act. They had already been listed since 2010, I think, under the California Endangered Species Act. But we didn't have too much on that. We did have one talk about life cycle modeling for longfin smelt, and we had several talks in general about life cycle modeling, for, both population and individual-based type approaches. I put there food and flow matter. They looked at other things as well. My overall impression was that this is a topic area that is very much under development right now. It's probably a little behind the salmon life cycle modeling, which is no wonder because delta smelt only occurs here. Salmon modeling is being done elsewhere a lot as well. And of course, it's also picked up some speed because of things like BDCP, et cetera, that need this kind of information. But there's a lot going on, so that was interesting. Then on Friday, we had a really long session about the fall low salinity habitat, now known as FLASH studies. Previously, you might have heard this referred to as fall X2, but it's really about the low salinity habitat in relation to all the other habitat around it and what that means for delta smelt. So this is all about delta smelt. And as I said, that is required. The study part remained required under the 2008 Fish and Wildlife Service delta smelt biological opinion. And we are working hard, rapid turnaround, as rapid as possible, a report about what we found with the studies that occurred last year and that were presented at this workshop, the preliminary results. And this is supposed to be part of an adaptive management approach, and it really is. And there's also an adaptive management plan, which is associated with this action. And all of this will be reviewed again for the second time by an annual panel of independent scientists put together by the Delta Science Program. Peter Goodwin was actually on it last year. He can't be this year because now he has this function, so we'll have to replace him. But in any case, that'll happen. That'll be a public meeting, and it'll happen in June or July. We haven't managed to set the date yet. But really this meant lots of intense new monitoring, or rather augmenting the monitoring that was already going on, complementing that with lots of other things, and studies that started in 2011. How we got there was a little weird, but that we got to do this was actually incredibly great because there was so much interesting stuff going on in 2011. And so the current approach to putting this together, and this is actually the integration I think that you, Mr. Nordhoff, talked about earlier, trying to integrate all these results then, is what we're trying to do in what we're saying now is flash analysis and synthesis. And to do that, we are focusing on 4 regions. 3 of them are by salinity, and 1 is geographic, the Cache Slough, Sacramento River Deepwater Ship Channel region. And you can see them here on that little graphic. The bluish colors is the low salinity zone. And then farther upstream there is, of course, the Cache Slough area. And also 4 years. In particular, we picked 2005, 2006, 2010, and 2011. That doesn't mean we don't also look at other years, etc., but we're focusing on this because we want to know if the habitat and predictions about fish that were made in the adaptive management plan, which includes a science plan, prior to this study and the year 2011 actually happening, if they were in fact accurate or not. And those 3 scenarios are actually these. 1 was with X2 at 74 kilometer, which we almost got in fall of 2011. We had it at 75 kilometer. 1 was with X2 at 81 kilometer, which we had approximately in the falls of 2005 and 2006. And then the final one was with X2 at 85 kilometer, which we had in fall of 2010. Obviously, in those years prior to 2011, we didn't also do all these other new studies that we just now put in place. So really, as far as the study itself is concerned, we only have 1 year. But in order to really say much, it's really a good thing to be able to compare. And this was also how our prediction table was set up. And so we have to use data that we have already from our long-term monitoring as well as some other additional studies in those other years, and that's what we're doing. So what happened in 2011 is not just of interest to us regarding the delta smelt, but we also have a broader effort going on that continues to focus on the pod fish species for the moment. It's now called MAST, IEP MAST, which is the IEP Management Analysis and Synthesis Team. And this is really sort of a stopgap thing approved by the IEP directors in December of 2011, basically asking the long-term existing IEP management team to do additional work, additional analysis and synthesis to tell the directors, the IEP directors, agency directors, but also you and others, stories or a story about what we're seeing out there, because with the IEP and many other programs such as the IEP, it's a problem that we are often more able to actually collect data and have lots of individual studies, but then we're never really quite able or somehow never seem to have the resources to really integrate it all and pull it all together. And we recognize it. We have asked many times over by now for additional funding, basically, staff people, to pull this off, to have a standing team to do this. It just doesn't seem to really ever come through. Of course, we're in budget crunch times, too. But in any case, the directors at least agreed to have the members of the already existing management team, plus a few additional staff helpers, work more on it. So we're working on this flash report that I already mentioned. We're also working on a broader report that includes all the podfish species and habitat conditions throughout the year, because of course we recognize that the fall is only one part of the year, and you can't actually understand anything about the fall without also looking at the rest of the year. And this is also intended to find gaps in our knowledge, things that are missing. And so this will then also include a work plan to address those things that are missing. And it will include relatively comprehensive assessments of both habitat conditions and fish responses in all seasons. And so to give you a flavor of this without actually going into details, so it really goes from the data collection right here to analysis by lots of individual people at their computers in the agencies as well as universities, to talking about what it all means in groups, and this is what this MAST thing allows us to do at least a little bit, time-wise, to then developing models, conceptual or if possible quantitative, and these assessments, which here we're trying to summarize things in a format where green means good, red means bad, yellow means somewhere in the middle. And this is actually for those 4 years that I mentioned earlier, and for delta smelt habitat components. And as you can see, it gets greener as you go toward 2011.
Is that good?
That's a good thing.
Okay.
However, and so many things, I'm not going to go through what these things actually are, but many things seem to align for Delta Smelt throughout the seasons in 2011 that explained, or we currently think explained, their uptick in abundance. With this caveat, of course, it's very preliminary, and we're still working on this, but we are trying to have something that's reviewable by this Delta Science Program panel in June or July, and then go from there.
Mr. Fiorini.
Thank you, Anki. That was very, very interesting. When there's a house on fire, the firemen respond with a sense of urgency. To read that 69% of the tethered salmon were devoured in 1 hour's time would suggest that the other 31% are probably in jeopardy too. That to me strikes a chord of a sense of urgency.
It was a 31, I think, percent, but anyway.
That was the survival, I think. So from a scientific point of view, describe how the science community views a sense of urgency, and what does it look like to the average person when the science community is sensing that something needs to be done about something right away?
Oh, the science community will just do more science. That's pretty clear, right? But to point this out to the policymakers, absolutely, that's our charge, and we're doing this. I'm doing this right here. I can think one previous example was in 2004 or 5, when the scientists noted that the fall indices, but really all the abundance indices of these 4 pelagic fish species seemed to be tanking all together at the same time, even though they had very different life histories. And so we literally wrote this up and sent it upstairs and said, we probably need to do something about this. And then the rest is kind of history. And so these things do happen that we call some things out, and then there is a response. The response is certainly twofold. One is with more science, because we didn't understand the pelagic organism decline back then. We understand it better now. I wouldn't say that we understand it completely, but we certainly made a lot of progress. And then things have come from it, like this fall X2 business, controversial though it remains, is one of the regulatory responses to what we've been looking at and finding. And of course, a lot of things don't make people happy, and so there will be controversial aspects to this, but the science marches forward with this. Yeah, and also I wanted to point out, maybe more for other folks here, but this was really fast, obviously in the interest of time, but I will be giving 2 more talks next week, one to the IEP stakeholder group, which is on May 2, and another one to the Delta Independent Science Board, who's also asked for a similar update on May 4, so I think I have a little more time then. But we're definitely wanting to do this in as clear and transparent a fashion as we possibly can. I'm actually regretting right now that I didn't bring sort of the flow chart that we have for both the workflow and the organizational structure for this MAST business, because maybe that would make that clear also. But it is really tricky because, science actually needs some time. Planning needs time, actually doing science needs time, and then trying to understand it all may need even more time because there are so many parts to it. But we are trying to do it as fast as possible, given that we understand it's obviously of some urgency, to do something about these things.
Hank.
Anka, you covered an awful lot of ground at a very high rate of speed.
Yeah, I worked hard on that. I'm also known for that, by the way.
I'm not a scientist, so a great deal of it had a very high flow rate right over the top of my head.
Sorry about that.
A couple of suggestions.
Mm-hmm.
I applaud your economy in squeezing 6 slides on 1 page, but it does make it difficult to read.
Well, that had to do with the hot off the pressedness. I actually really appreciate the comment, and I apologize for it also. But I didn't get around to doing this presentation this morning, and my home printer is so slow, so I had to be fast.
You do sound a bit pressured. Do you drink a lot of coffee in the morning?
Oh, I think I've probably ingested a gallon by now.
I'd stay away from the caffeine.
But you folk basically keep asking, "What's the answer?" and we're really trying as hard as we can, and it really does mean, I'm just not kidding at all, lots of night shifts and lots of coffee, because this stuff ain't that easy, it's very complex.
We know. Would you do me a favor, in addition to cutting down on the caffeine before your next presentation, would you just summarize the 3 most important things you carried away from the conference?
Mm-hmm. Sure. Well, for one thing, I was really pleased, and I didn't even say that before, by just the flow of some of these sessions, which you asked about this integration thing. I really think some stories emerged, like in the salmon session, for example, and that isn't really because it's supposed to result in a report, like with the flash thing, but it just happened, perhaps, it was well organized. This whole thing about survival, that the survival has declined, is declining, at least in some parts of the system, as the salmon migrate through the delta, and the route selection, that really matters, and of course that means something to management. I didn't get into it, but John Bureau, for example, talked about how the delta cross-channel could be operated to steer salmon one way or another. It's an option. And then, the fact that the hatchery salmon are starting to really take over, and part of the reason for that, and I didn't mention that earlier, but it's an important reason, I believe, is because they're trucked around the delta rather than swimming through the delta. Winter-run salmon do actually have a bit of a hatchery input, but they're not trucked. So that might be part of the reason for their...
I'm sorry, they're not thrust?
Trucked, as in put in a truck and dumped out in San Pablo Bay. So from the hatchery, not into the river, not into the estuary, but basically straight into the ocean, more or less. So, there are reasons, and these stories are coalescing. For the fall story, there is also a coalescing, I believe, which is that there were responses to flows that were throughout the ecosystem. We saw these interesting differences, and I certainly won't get into those, in the biogeochemistry, in the food web, and then all the way up to the fish, in between, for example, 2011 and 2006. And they were quite similar hydrology-wise on some level, but there were also some important differences, and how these things are coming out, to me, is really fascinating and actually promising. I think, the question then is, what are the management knobs, of course, of interest perhaps more to you. But you first have to understand these things. But I do think some things are starting to come up. So that's pretty cool. And again, also the other thing, Peter mentioned it, there was a lot of interesting new tools being brought to bear. And approaches.
You mean
analysis.
Real cool technology?
Real cool technology. And approaches also to the analysis, to the modeling, to the synthesis. So that kind of stuff is also pretty neat. Our working together again with the QEMF, with the California Water and Environmental Modeling Forum, was a really good thing. We had a joint day with a joint poster session. The modelers, many of whom are engineers, and the IP folk, many of whom are biologists, really do need to talk with each other, and I think that helped that we had these meetings back together. So, because then in the end, through the modeling, through the analysis and synthesis, that's when it gets to you, and when it becomes more of a story and more of interest to you, I think. So.
Thanks.
All right.
Okay.
Thanks, Uncle.
We're going to take a 5-minute break.